Hey everyone, welcome back. Today we are going to look at parting. So this is PEC parting using the VersaGroove tool, and we're going to be cutting off these tiny little slivers. But more importantly, I'm going to show you how to generate the code to do that in Excel, and then we're going to basically export G-code from Excel, put it into the Raspberry Pi, and then run the part on the lathe. But the focus of today's video is pretty much going to be Excel and the G-code generation. So we're not going to spend a lot of time on the lathe, but I will show you the carbide tool cutting through that material because it's pretty sweet. We're going to look at generating G-code using Excel to do the heavy lifting. So here I've got a spreadsheet that will create a pattern of parting cuts. And this syntax you see here might be a little bit different from other G-codes you've seen. Still G-code, but this happens to be the Barrel CNC Beryllium format, which is the free software. So we have a keyword barrel in the A column, then we have a line number indicated by N in the B column. C is the actual line number. This will get appended to that N. We have our G-code term. In this case, it's a G1 straight line move. We have our X, which is going to be appended to its numerical value. Then we have a Z, we just put that already with its numerical value of 0 since we're going to just keep the Z at 0 for this parting experiment. And then we have our feed rate. So let's start. What we're going to do here for our strategy is basically approach the material pretty fast. Then we're going to slow down, take a PEC cut, and then zoom back to the safe X. In this case, our safe X is 0.375. We do the X, which is the radius here. We don't operate in diameter mode, typically with Barrel CNC. So everything you see in X is the radius away from the Z-axis, which would be X0. Okay, so first let's just go through these numbers here, and then we're going to use Excel to do its magic and generate all of these X terms for us. 0.375, that is our safe X. We've got 0.350, which is going to be pretty darn close to starting to engage and cut the material. And then 340 is where we're assuming that we are actually 10 thou below the 350 mark in X. And at that point, we can assume that we're going to be starting to cut material. We go ahead and regenerate those three lines based on safe X, approach to within 10 thou of the material that we're cutting, cut into it by 10 thou, and repeat. So we're going to take these three, select those, and just drag them down and go to let's go to over 100 here. And let's look at really I just want it to go to 0. So the 0 term here, that looks good. We'll just go ahead and let's say that 375, we'll let it go back to its safe X there. Let's just delete these extra ones here. Delete those, we'll go back up top. Now, same thing for our feed rates. We just want to duplicate F30, F4, F1 in that same sequence. So we'll highlight, select, I should say, these three, drag them down to as far as that column F goes. And there we go. Now, let's fill everything else in. Just drag these down. So I'm trying to do this as simply as possible and as obviously as possible. There's our line numbers. We're going to make sure that those fill series so that they actually count. G1, we're just going to copy these. It's all G1 straight line moves. X is X. Copy those down. Just our capital X term. It's going to end up going into our string. And Z0. Copy that guy down. Now make sure that this is copy cells so that they're all Z0. That looks good. Okay, Now let's go ahead and append everything together that needs appending. Alright, so column J is just going to be equal to barrel. Column K is going to be equal to N ampersand, quote, quote, ampersand, this C term here, and that's going to append those together. So now we've got, see, our N0 again. Now for L, that's just going to be equal to G1. For M, what we're going to do is basically append the X to its numerical value, but we need to sort of cast that to a precision so that we don't get any weird, 10 decimal places from Excel or anything like that. So we're just going to do equals the X and then ampersand, quote, quote, ampersand. Now here's where we're sort of casting it to text. We're going to type text, and then we're going to give it that first term there, comma, and this is where we give it its precision, 0.000, close parentheses, and there you have X 0.375. Now for N, this is just going to be equal to that Z term that we sort of fudged and already appended it to its 0 just to make life easy because we were at Z0 for everything. Finally for O, we're going to just make that equal to the V rate value there. Alright, now let's go ahead and just drag this down the whole way to the end. And there you go. So you can see everything looks good. Let's make sure we save it. Now we're just going to highlight everything in this right-hand appended grouping of cells and just Control-C that. And we're just going to paste that into a text file and then copy that over to one of our barrel jobs. We'll do barrel job 10 in this case. There we go. We just pasted everything. Let's get rid of that last blank space there. And that's our G code. So we're just going to put that in the barrel job. I'm going to move over to my Raspberry Pi and continue pasting this into the barrel job file and then doing a test run on my desktop Raspberry Pi just to make sure everything's happy before we move over to the CNC and actually start cutting some metal.
Alright, so let's find barrel job 10. I'm just going to go Beryllium, Programs, barrel job 10. And let's go ahead and paste. Alright, there's all of our code that we generated. And I'm just going to call this the PEC parting test. Save it. Let's click on barrel job 10. And it's going to take a second to read that in. And there we go. There's all of our code there. 105 lines. So it's going to parse all those lines, send them to the Gerbil controller, do its thing, and it's kind of hard to see, but there's a skinny little green line there showing that that's where we're running this parting program. So I'm going to turn on some motors, and let's go ahead and cycle start. And I'm just going to speed this up to 200% so you can see it go. As you can see by this yellow circle, the tool is basically just parting through this in a pecking fashion. So that clears any of the stringers and chips and things like that so that it gets out of the way. We don't have any secondary chip cutting or binding. Keep in mind too, as you're parting through something, that material is heating up and expanding. So the expansion you get in a slot wants to grab the tool and rip it off the tool post. So that's why the PEC parting is very beneficial in this scenario. Is it every time that material starts expanding and you take another peck at it, you're basically if you have to, you're skimming off maybe another couple tenths of the material so that it's not in the way for subsequent cuts. All right, thanks for watching, everyone. Hopefully you found that G-code generation from Excel not too boring. Looks like you made it this far, and we'll see you next time. Adios.